Welcome to today's video. In today's video, we're going to be synthesizing a compound known as aspirin. Aspirin is relatively easy to synthesize and it only takes 2 to 3 ingredients, but I thought it'd be a good first project since I'm not very experienced yet. But first, let's talk about what aspirin really is. Aspirin is a derivative from a group of drugs known as salicylates, which are from a compound called salicin. Salicin was originally extracted from the white willow tree, which is typically found in Europe, North Africa, and Central Asia. But nowadays, the white willow tree also grows in North America due to people bringing it over and planting it. It's been what's called naturalized. Salicin was first isolated and crystallized by pharmacist Henry LaRue in 1828. Salicylic acid and aspirin are super similar. The only real difference is that with salicylic acid, instead of all of this, there's just a hydrogen. It's just an OH group. So what we're going to do is we're going to react salicylic acid with something called acetic anhydride, and what that is going to do is it's going to tear off the hydrogen off of our salicylic acid. It's going to tear off a carbon from our acetic anhydride, and it's going to make a covalent bond to connect those two groups together to form aspirin. How does aspirin actually work once it enters your body? Well, like I said before, your body's going to convert that aspirin right back to salicylic acid, but it's going to do this in your liver and your small intestine, so you don't have to deal with the irritative effects of it. Anyway, what then the salicylic acid is going to do is it's going to suppress the production of local hormones known as prostaglandins. This is done by binding to an enzyme called cyclooxygenase. This enzyme is the enzyme that's actually responsible for the production of the prostaglandins, and prostaglandins are responsible for the transmission of pain. So if you suppress whatever's responsible for the transmission of pain, you're going to have less pain being able to be transmitted. Next, let's go quickly into how we're going to synthesize our aspirin. So, it's going to be really simple. This is about as simple as it gets when it comes to synthesis. We're going to do a simple SN1 reaction, reacting salicylic acid with acetic anhydride, and we're going to use something known as phosphoric acid as our catalyst that's going to drive along this whole reaction. It's going to be quite simple, and I guess let's get into actually synthesizing, and then we'll go over how to make sure that we actually have aspirin, and then we'll go from there. So let's get right into it. I started off just with a round bottom flask and put a funnel in, and then started funneling in my salicylic acid. Now, it was a little bit goofy of me to use this funnel because I found it really hard to actually get the salicylic acid to go through the funnel. So I ended up having to use a stir rod and a straw to push it down. This part of the video is obviously sped up. But then I washed it down with a little bit of acetic anhydride, and these were going to be the main two parts of this reaction. After I poured in my acetic anhydride, I gave it a little push and it all drained into the flask. Next, I just threw in a small stir bar in order to get this reaction stirring nicely. Once I had the solution stirring, I just let it sit there. I knew that it needed a little bit of time to dissolve, and I was going to add in my catalyst soon. For my catalyst, as I mentioned before, I was using phosphoric acid. I didn't need very much, I only needed a few drops. I then just let the reaction sit for a bit because I knew that there needed to be some time for the synthesis to actually occur. But after I let it sit for a while, I knew that it was probably time to put it through a filter. Once I was ready, I took the flask off of the clamp and gave it a little swirl. I could see that there were a lot of particulates in there, and I was hoping that this was going to be my aspirin. I set up my vacuum filter and started pouring in what I hoped would be my aspirin in. But as you'd see later in the video, I was getting my hopes up. I gave the flask an extra wash just to make sure that I got as much of my supposed aspirin as possible, and then dumped the whole thing. I gave my nice white powder a good wash with some DI water just to dissolve any acetic acid that might be there, as well as I gave the flask one more wash, and then all I had to do after this was just let my nice white powder dry. I took my filter and I decided to dump all my white powder directly onto a scale because I was anxious to see what kind of yield I got. I dumped it all out onto the scale, and as you could see, I got a pretty decent yield of over 4 grams, starting off with 6. But I had to actually make sure that this really was aspirin and not something else. What I have here is a really fancy melting point apparatus that is pretty much going to be able to tell me if this is aspirin based on when my sample melts. So all I had to do was get a little bit of aspirin in a tiny tube and then just set up the apparatus to heat up to 140 degrees. If this was truly aspirin, then I should see the white powder melt at around 135 to 136 degrees C. Unfortunately, once this got up to that temperature, I could see that it hadn't melted yet. So to see what was going on, I added a known sample of aspirin to see if it would melt. And of course it did. So at this point, I was pretty sure that I hadn't actually made aspirin, and I was pretty sure that what I had made instead was actually nothing. I believe that what I had here was just salicylic acid that I had added into the reaction in the first place. This was pretty annoying because this was supposed to be a really straightforward, easy synthesis, but I knew that I had to try again because that would just be embarrassing. So once again, I added some salicylic acid, this time only using 5 grams, followed by some acetic anhydride. This time, however, I decided to do all of this in just a regular beaker because it would make it a lot easier to get whatever I made out of it and into the filter. I dropped in the stir bar and it instantly started stirring, and now all I had to do was wait for everything to dissolve. Once my solution had turned clear and it was obvious that everything had been dissolved, I now knew that it was time for me to add my catalyst. I used some concentrated phosphoric acid, and I knew that I'd only need a few drops. Once I had finished adding all of my catalyst, phosphoric acid, I decided to let it stir, but then took it off pretty quick, which, as you will see in a second, led to pretty bad results. All I had to do was put my solution into an ice bath. This would promote crystallization of what hopefully would be aspirin. Crystals quickly started to form at the bottom of the solution, and this made me excited because last time I hadn't really gotten any proper crystal growth. There was still a chance that it hadn't worked, but I still had my hopes up for this trial. A really cool snowflake pattern kind of seemed to take over, but by the time that it was done crystallizing, there was almost no liquid left. Once I had felt the crystallization was done, I removed my beaker with all my crystals out of my ice bath, and as you can see, like I said before, it was almost completely crystal. There was almost no liquid left. I used a spatula to dig out all the crystals and dump them into the filter so that I could get them nice and dry. But I knew that, I still knew that there was a chance this wasn't aspirin. I still needed to do my melting point check. Once I had a nice dry powder inside of my filter, I decided to take it off and once again throw it straight onto the scale. I dumped it on, and I got a pretty decent yield this time, around over 4 grams once again. But I knew that I couldn't get my hopes up because last time I'd also got a very similar yield, but it turns out that I hadn't really even done anything. Once I had gotten my sample into my apparatus, I then started ramping up the heat, and unfortunately, nothing really happened. It didn't melt, which, this meant that I'd failed again at just simply making aspirin. I kept ramping up the temperature, and just to confirm that it was still just salicylic acid, I went up to 160 degrees Celsius, and it melted at about 158. I was getting a little bit frustrated at this point, so I got a small beaker, threw in all my ingredients that I needed, 5 grams of salicylic acid, followed by around 10 milliliters of acetic anhydride, and put it into stir. Once I had everything nice and dissolved and the stirring was going good, I just needed to let it sit. The biggest difference this time was I was going to let this stir and synthesize for 40 minutes. And this seemed to do the trick because I also got nice crystallization here, and when I finally dumped out my powder, I was really anxious to see if I had actually made it work. Could I really label this aspirin? We'd have to find out. So instead of just doing a melting point test, I wanted to be extra certain that what I had here was really aspirin. So what I did was I decided to use another kind of test that's qualitative. I got 3 test tubes and filled each one with 2 milliliters of 0.1 molar nitric acid, followed by 1 milliliter of 0.2 molar ferric 3 nitrate. I then assigned each test tube a sample. 1 and 2 were both standards. 1 was aspirin, 2 was salicylic acid, and 3 was whatever I made. I gave each test tube a good stir, and the first one came out orange. The second one came out a nice deep purple. And the sample that I had made, as you'll see, what would it come out to be? Well, this was the big moment to see if I had actually made aspirin. I gave it a stir, and nothing was happening. But this is exactly what we wanted. Aspirin wouldn't react in this reaction because there's no OH group for the ferric nitrate to react with, which means that the chance that I had succeeded had gone up. But just to be extra safe that what I had here was truly aspirin, I decided to still put it in my melting point apparatus, and just as it was reaching around 135 to 136 C, I saw that my sample had melted. So at this point, I was almost positively certain that what I had here was truly aspirin. I was really relieved at this point because I don't know what I would have done if I couldn't synthesize aspirin. But I'm happy that I did, and I learned a lot from doing this. I look forward to future videos where I tackle more challenging problems and more challenging chemistry issues. I want to thank you guys so much for making it this far into the video. I think that it's pretty safe to say that I successfully made some medicine, some aspirin, the stuff you'd buy at the store. I've successfully synthesized it here. It passed 2 tests. We did a colorimetric test as well as a melting point test, and they were both positive for aspirin. So, yeah, as you can see, the synthesis of aspirin is pretty simple, but yet it still took me 3 tries. 1, probably because I'm not a great chemist yet, and 2, just because chemistry can be a pain in the ass sometimes, and when things should work in theory, sometimes they don't work in practice, or maybe there's just something random that you're doing wrong. But anyway, whenever you're doing chemistry stuff, it's just important to just keep on trying, because eventually if you keep trying, you will succeed. I'd like to thank you guys so much for watching. One more quick shout out. I'd like to thank the sponsor of this video, which of course is the New Mexico Institute of Mining and Technology. Without the New Mexico Institute of Mining and Technology, and specifically the chemistry department, none of this equipment and none of this around me would be possible to be used in the videos. We have 4 great fume hoods, all the glassware we could possibly use, as well as some really cool equipment like boiling point apparatuses and all sorts of stuff like that. So I really want to thank them for contributing so much to these videos, and for putting a lot of time and effort into getting the equipment that this YouTube channel needs. I also want to emphasize that if there's anyone out there looking for colleges, I highly recommend going to the New Mexico Institute of Mining and Technology. There's just so many more opportunities at this kind of small school that you're not going to get at larger universities. You're going to be guaranteed research experience, as well as many other opportunities, just as long as you try and just as long as you ask. That's all that you really got to do. Yeah, so I recommend the chemistry department, of course, but even if you don't do the chemistry department, all the departments here are great. And yeah, so just a shout out to New Mexico Tech. Anyway, please like and subscribe. We're growing. We're almost at 400 subscribers, probably at the time of the posting of this video, and we're climbing our way to 1,000. There will be 1,000 subscriber special I'm very excited for. And thank you guys so much for watching. I'll catch you guys in the next video.